Okay, we learned that average velocity is the slope. So if you've got a line right there, the slope between 2 points, and that line connecting them in calculus is typically called the secant line. Well, instantaneous rate of change is also called instantaneous velocity, and every time we're doing this, when we're talking about instantaneous velocity, it's always at a given point. So for example, this rate is going to be different than this rate, which is going to be different than this rate. So it's always at a given x value, or sometimes it's the t value, for instantaneous rate of change. Also called slope of the tangent line at a given x value. So when we're talking about instantaneous rate of change or instantaneous velocity, oftentimes we write it as m sub tangent. And as we start to learn about the derivative, that's what the derivative function provides. The derivative function provides the slope of the tangent line, or instantaneous velocity. Okay, before we get started into that, we're going to harken back to the difference quotient in pre-calc, and it's this process using the limit of that difference quotient that gives us our first intro to the derivative. So we're going to find the derivative via the limit process. And remember the difference quotient, it's a composition of functions. So every time there's an x, in this first part, it's f of x plus h, then you subtract the original. So this is the composition. Subtract the original all over h. Some professors use as delta x approaches 0, and then instead of h, you'd put delta x. They mean the exact same thing. So for example, if we're given this function, 2x squared, we're going to plug that 2x squared into the difference quotient, and we're going to use the limit process. Sorry about that. Video just uploaded. All right, so here's our function right here, 2x squared, and where that x is, we're going to plug in x plus h. So 2 times x plus h squared, subtract the original, all over h, and then you're going to expand it. And remember when you're doing Pascal's triangle, x plus h squared would be x squared plus 2xh plus h squared, and that's what I expanded right there. And then you're going to do the distributive and simplify. So that's what I did here. So this becomes 2x squared plus 4xh plus 2h squared. And then we're going to subtract that original. And a second ago, I had one of these boxes that said cancel. Well, what you should notice is this positive 2x squared cancels with this 2x squared. So now I'm going to simplify and rewrite. So now we have 4xh plus 2h squared all over h. Well, look at what they all have in common. They all have at least one h in common. So we're going to factor out that h. And when we do that, we can cancel, leaving 4x plus 2h. Remember, we've done the limit process. Well, now that we have it down to this, we can substitute in the, for h, we can substitute 0. So 4x plus 2 times 0, that cancels. So the derivative function, dy dx, is equal to 4x. And then depending at where you're at on the graph, so if x is 1, the slope of tangent will be 4. If x is 2, the slope will be 8. You get the idea. All right, that's it. Well, we're going to do another one, but that's it for introducing using the limit process to find, this is just the derivative function, and then later on when you're given certain x values, that's when you'll find the slope. All right, that's it.